Hello everyone, welcome back to my channel. Today let's learn about the DFA to accept strings of A's and B's having odd number of A's. Okay, so here what we have to do, we have to design the machine that accepts odd number of A's, and then we have to reject the string which has even number of A's. So let's begin. So in this problem, what is our goal? Our goal is to design a DFA to accept odd number of A's. So our goal is to, one thing is to accept odd number of A's, which means we can accept A, or 5 A's, right? 1, 3, 5, 7 like that. Okay, one thing is that. And then we have to reject even number of A's, right? We have to reject even number of A's, which means A or no A or A like this. And one more thing is there. Remember, we have to accept strings of A's and B's, right? So here B can be anywhere. It is like a superpower. It can be anywhere and it can be in any number. Okay, so anywhere and any number. So these are our goals. So now in the next step, what we have to write? We have to write the alphabets, right? So the alphabets are A and B. Now tell me, what are all the languages? Languages can be A or B or we can write A B A, so on, which means we should have odd number of A's and we can have any number of B's, right? So here in the first term we have 1A. 1A means one character, means we have to take two states, right? So we need two states. So all these things are clear now. We wrote about alphabets, languages, and what are our goals and the states required. Now it's simple. By taking all these conditions, we have to write the transition diagram. So since we have taken two states are Q0 and Q1. Okay, Q1 will be the final state, that is the accepting state, right? Accepting state means here it has to accept odd numbers only. So odd numbers. So this is the state to accept odd numbers because this is the final state. So Q0 is a state which is going to accept or going to have even number of A's, right? So if it is a even number of A's, then it should be accepted here, which means this is the rejecting state, right? Which means only the final state is the accepting state. So if even number of A's is there in Q0 state, then the state will get, or the string will get rejected. So let's write the transition diagram. So we have only two states here, Q0 and Q1. One thing that is common here is Q0 on A moving to Q1, right? Q0 on A moving to Q1, that is odd number of A. Now let's solve it for A first and then we will have to solve it for B, okay? So Q0 on A is moving to Q1. Now what if I get A in the Q1 state? So there are two cases. One thing, it has to go to Q0 state, other it should be there in Q1 state only. So let's check what to do if it is there in Q1 state. So let's check. Q0 on A moving to Q1 and Q1 on A staying in Q1, but it is an odd number of A's. So this transition diagram is not correct. So I can't take the A here. Now another case is Q1 on A moving to Q0. Check this one. Q0 on A moving to Q1, and then Q1 on A moving to Q0, and this is not the accepting state, this is the rejecting state. So our diagram is correct. So let's take, there is another one A, which means we have example of A. Q0 on A moving to Q1, Q1 on A moving to Q0, again in Q0 we have A, so it is moving to Q1. So the string will get accepted. So for now Q0 and Q1 on A is done. Now we have to write it for B, right? So here we can have any number of A's, right? So we can ignore B. So if we want to ignore B, what we have to write? We have to write self loop, correct? Which means Q0 on B. So let's check this one. Let's take, we have an example of B, A. This should get accepted, right? Because 3 number of A's. Q0 on B, it will be there in Q0 state only, and Q0 on A moving to Q1, Q1 on A moving to Q0, and Q0 on A again moving to Q1. It is done. Now Q1 on B, this one also we can ignore and we can write it as a self loop. Check it again. Let's take an example B, A, B. Okay, 3 number of A's. Q0 on B, it will be there in Q0 only. Q0 on A moving to Q1. Q1 on B, it will be there in Q1 state only. Q1 on A moving to Q0. Q0 on A moving to Q1, and Q1 on B, it will remain in Q1 state only. So this one also get accepted. So this is the simple transition diagram for a string of A's and B's having odd number of A. Okay, so let's take some of the example and check whether our transition diagram is correct or not. So the first example is A. So what will happen? A is an odd number. Check that one first. This is odd. So Q0 on A, it is moving to Q1. So this string get accepted. This is the final state. So this one is a string getting accepted and transition diagram is correct for this example. Now this is a null set, which means we don't have A or B. This one should get rejected. Why? If there is 0A, then it is considered as even number of A, right? So here this one should get rejected. So this will not enter this state. So this one will get rejected. And we have A. This one should get rejected, right? So let's check. Q0 on A. Q0 on A moving to Q1. Done. Q1 on A moving to Q0. This is not the accepting state. So my transition diagram is correct. So now we have A, B, A. A, B, A should be the rejecting state. Why? We have 2 A's, right? So Q0 on A moving to Q1. And then we have B. So Q1 on B, it will be there in the Q1 state only. And Q1 on A, Q1 on A, it is moving to Q0 only. So this one is also getting rejected. Now we have BA, BB, AA. What is the thing we have? BA, BB and BA, right? So Q0 on B, self loop. Q0 on A, moving to Q1. And Q1 on B, it will be there in Q1 only. Again B. So it will be remain in this state only. Now on A, it is moving to Q0. And again we have A. It is moving to Q1. So this is the accepting state. So this string get accepted because it has 3 number of A's. Okay, and still there are 3 more examples. You have to check this and let me know the answers. Okay, so let's write the transition table. To write the transition table, we have to write the states Q0, Q1, and we have to write the input symbols that are A and B. Right, so Q0 on A moving to Q1. That one we have to write it here. Okay, Q0 on A moving to Q1 and Q0 on B. It will be there in state Q0 only. And then we have Q1 on A. It is moving to Q0 only. And Q1 on B. It will be there in Q1 state. So this is how we write the transition table. That's it for today's video. I hope you understand this concept. If you did, please don't forget to like, share and subscribe. Thank you.